Okay, so in this video I'm going to do an indefinite integral by the method of partial fractions. So it's integral of x minus 1 over x cubed plus x dx. So for method of partial fractions, we first want to factor the denominator. And then we want to write the integrand as a partial fraction decomposition. So this is x minus 1 over x times x squared plus 1. And our partial fraction decomposition says there's one linear factor, x minus 0. So I write this as a over x. And there's one quadratic factor that's irreducible. So partial fraction says I write this as bx plus c over x squared plus 1. And now I want to solve for a, b, and c. So to solve for a, b, and c, I'm going to multiply both sides by the common denominator, x times x squared plus 1. And I get x minus 1 is equal to a times x squared plus 1 plus x times bx plus c. And I can substitute x equals 0 to get rid of this term. And that will allow me to solve for a. So if I substitute x equals 0, I get negative 1 is equal to a times 0 plus 1, so that's a, plus 0. So a is equal to negative 1. And now that I know that a is equal to negative 1, I can substitute that into this equation. So this I can write as negative x squared minus 1 plus, and then I can expand this out, bx squared plus cx. And so I have this equation. I'm saying this side is equal to this side as polynomials. And so I can solve for b and c by moving this to the other side and identifying coefficients. So if I move this negative x squared minus 1 to this side, I get the following equation, x squared plus x, and then minus 1 plus 1 is equal to bx squared plus cx. If these polynomials are equal as polynomials, then the coefficient in front of the x squared term has to be the same on both sides. So b has to equal 1. And the coefficient in front of the linear term on both sides has to be the same. So c has to equal 1. So I found that a is negative 1, b is positive 1, and c is positive 1. And so I've written my integrand as a partial fraction decomposition. So this integral is equal to the integral. A is negative 1, so negative 1 over x plus x over x squared plus 1 plus 1 over x squared plus 1 dx. And now I know how to integrate each of these pieces. So this is equal to the integral of negative 1 over x is negative log of x. The integral of x over x squared plus 1 is 1/2 log x squared plus 1. You do that by letting u equal x squared plus 1. That's a u substitution. And the integral of 1 over x squared plus 1 is, we did this in class today. This is arctangent of x plus c. And so we found our antiderivative.